Boa noite a todos, sejam bem-vindos a mais uma aula do curso de Neurociência Cognitiva, né? O curso internacional de Neurociência Cognitiva. Então, um grande prazer ter todos aqui. Estou aqui já acompanhando um site dos mais animados, empolgantes aqui para a gente ter a nossa aula de hoje. Tem muita gente que está chegando nova ao curso e que está assistindo até as primeiras aulas. Então, para quem está chegando agora ao curso, seja bem-vindo ao nosso curso. Quem não tem ainda experiência de como é que funciona, o curso tem as aulas presenciais aqui, mas que ficam todas guardadas no YouTube, no nosso canal aqui. Basta ir na parte de live do canal, tá? E as pessoas que quiserem ganhar o certificado, elas poderão tranquilamente receber o certificado se elas tiverem pelo menos 75% das aulas do canal, tá? Então, do curso, né, 2024. Todos os links para as frequências estão na descrição dos vídeos das aulas, tá? Se eu não estou enganado, a gente teve umas 4 aulas sem o link. Nas aulas que não tem o link, a frequência foi liberada, então não tem por que se preocupar, tá bom? Então, eu vou chamar aqui o nosso amigo aqui de todas as aulas. Professor José Aparecido, boa noite. Tudo bem?
Boa noite, Givago. E boa noite a todos os colegas que estão nos acompanhando ao longo dos últimos 2 meses, quase 3 meses. Sejam sempre bem-vindos. E seja bem-vindo o nosso palestrante de hoje.
Hoje eu vou pedir a licença para o professor José Aparecido para que eu faça a apresentação do palestrante, tá? Eu sei que o professor José Aparecido é como se fosse o Pedro Bial. Desculpa a comparação, professor, não sei se lhe agrada.
Mas
é o Pedro Bial do Big Brother, aqueles textos lindos que vale a pena, talvez, criar uma nota, um livrozinho só com as apresentações do professor José Aparecido. Mas aqui hoje, o nosso palestrante, eu tive muito contato com ele. Eu pude ter o prazer de trabalhar com ele durante, acho que quase aí de 5 a 7 anos, praticamente. Ele esteve no Brasil, trabalhando na Universidade de São Paulo. Nesse período, eu tive o maior prazer de compartilhar com o professor Russell Hammer a experiência dele na área de ciência visual. Então, só apresentar para vocês, hoje a nossa palestra vai ser do professor Russell David Hammer, que ele é o tipo da pessoa que ele sempre está envolvida com grupos muito fortes, assim, ele sempre está dentro de grupos muito fortes. Ele trabalhou numa época na Smith-Kettlewell Institute, na Califórnia, onde ele acompanhou uma revolução no conhecimento da ciência visual, que era a compreensão da funcionalidade de fotorreceptores, e ele trabalhou de forma brilhante nisso daí. Outra coisa que ele trabalhou foi no desenvolvimento de métodos de registro cortical no cérebro, de forma não invasiva, no cérebro de bebês. Então, também foi incrível. E aqui no Brasil, o Russell ele teve um papel importante no laboratório da professora Dora Fix Ventura, não só como pesquisador, mas também ajudando na formação de qualidade de uma série de estudantes, de uma geração, praticamente, de estudantes de mestrado e doutorado nos programas de pós-graduação em Psicologia Experimental e Neurociência e Comportamento, lá da Universidade de São Paulo. E, além disso, a influência dele foi tanta que chegou até mim, aqui em Belém, e outros colegas meus aqui da UFPA. Então, somos muito gratos por toda e eu, especialmente, como amigo também, tá? Além do grande cientista, o Russell é um grande ser humano, é um grande amigo, e o mais importante, o Russell é um grande dançarino de músicas caribenhas. Ele deu aulas de músicas caribenhas na USP, e as aulas dele tinham acho que é ruedas, depois ele pode nos explicar melhor, com um monte de alunos. Sempre foi uma pessoa extremamente alegre, e é com grande prazer que eu chamo aqui para a mesa o professor Russell Hammer. Russell, boa noite.
Boa noite, muito obrigado. É noite em vários lugares, mas
Sim, sim.
possivelmente, por exemplo, estou em... não temos noite aqui. So, boa noite. Bem-vindo a colegas, amigos. Estou com muitas saudades do Brasil, de vocês. Zhivago é uma pessoa super importante, um amigo grande, super inteligente, criativo, e sempre aprendi coisas dele sobre assuntos. Yeah.
Já ganhei meu dia. Então, o professor Russell...
Ele pode cantar todas as músicas dos Beatles.
Isso é verdade.
Milhares de músicas. Ele aprendeu todas as letras em inglês antes de saber a significância das letras.
É verdade. Então, para o pessoal da audiência, apesar do professor Russell falar em português razoavelmente bem, ele vai dar a palestra em inglês, porque se fosse falar em português, demoraria muito.
Infelizmente, meu português não é adequado dar esta aula eficientemente e sem milhares de erros horríveis.
Maravilha. Então, Russell, vou compartilhar a tela da sua apresentação. Eu e o professor José Aparecido saímos da tela e voltamos após a sua aula para conversar com a plateia, com a audiência. Tá bom?
Ok. Começamos agora?
Sim, pode começar.
Ok. Let me know if everything looks okay. Tudo bem there? Looks good? Can you hear me?
Eu tô vendo o PowerPoint, não a apresentação. Talvez seja o caso de compartilhar a tela inteira, Russell.
What do you see? What do you
I see your PowerPoint, not the presentation. I see the PowerPoint window. Try to share the presentation.
Okay.
Let's see.
Stop screen.
And or maybe share your full screen. It's easy.
Yeah, I know, but I have two monitors. I'm trying to figure out.
Okay.
What I'm saying. Present.
We are seeing your monitor one, I think.
I know, you need to see the other monitor.
Yeah.
Oh, no, it's asking me what to share. Which window?
Let's see.
Let's do that. E agora?
Let's see.
Agora?
PowerPoint presentation. I think it's your computer you are sharing.
Oh, shit. Merda.
Well,
wait. Do you want me to?
Okay.
I can try and just do it on one screen, I guess.
Yes. Okay. Maybe if you zoom your presentation, it's okay also.
What do you mean?
Yes. A little bit more.
Let me move this down.
I think it's okay now.
What do you?
We can see your PowerPoint.
Do you see my cursor?
Yes, I see your
cursor. My cursor moving on the screen. Yes.
But your presentation is not complete.
Now what do you see?
The slide is not complete. Não vejo seu monitor, não vejo.
Okay, I'm going to move it down.
A gente está vendo a janela do PowerPoint.
I'm going to move it down to this monitor.
Okay.
Peraí.
That's
I'm moving it down to this monitor. And now I will...
É que o pessoal está sugerindo aqui, é que ele está com 2 monitores, então só está conseguindo compartilhar um monitor.
Que veja agora. What do you see?
I see your PowerPoint presentation. If you want, you can send me your presentation. You can send me your file. And
No.
Share for you. No? Okay.
It's too big.
Yes.
This should be easy.
Yeah.
Stop sharing. Now I'm going to present.
Full screen.
Share screen. I know. I've done this many times on Zoom, unfortunately.
Let's see.
Share screen. That's not good.
Let's see.
Do you see my cursor?
No, we are seeing the platform here. Eu acho que está acontecendo porque você está com 2 monitores, Russell. E a plataforma está pegando sempre o monitor número 1. Deixa eu ver.
I'm really sorry.
Don't worry.
We tried this before.
Move it to PowerPoint. Move it to PowerPoint.
And it was working, remember?
Yes, move it to PowerPoint.
Remember, it was working earlier.
Yes. Okay.
Share screen. Share screen.
Let's see. We are seeing your presentation. Your power. Oh, now. Let's see.
Okay,
yes,
where we go.
Are seeing,
yes.
Yes. Okay, Russ. Yes.
Ok. Gente, finalmente, a beleza no cérebro. A aula de hoje se concentrará na base cerebral da experiência estética em humanos. O título original is this one. A Mona Lisa de Da Vinci é apenas mais sabor de chocolate. And here's the Mona Lisa, painted by Leonardo in 1503. And I'm going to focus on it and talk a little about the multidimensionality of the aesthetic experience. And I'd like to introduce the topic with this fantastic surreal painting by the artist René Magritte, a Belgian surreal artist, called The False Mirror, Espelho Falso. And the reason I want to open the talk with this image is because I think it introduces the topic very symbolically and appropriately, because what Magritte has done here is he presents this fantastically huge eye that has no eyelashes. And what do we see inside this giant pupil? We see blue sky and clouds. And so what Magritte has done here is he has brought us to the interior experience of this viewer, this enormous viewer. We're looking inside at what they are experiencing. And that is appropriate for the topic today, because the aesthetic experience and the experience of beauty is a very private internal experience to each of us. So I'm going to start by talking about art, but of course beauty is not restricted to art, but it happens to be a good example. And we know from the historical record that making art, or some things that we would call art, seems to be very fundamental and very ancient in Homo sapiens. There's evidence for art making dating back at least 51,000 years. Here is a fragment of a pig, porco, from the Sulawesi Island, a cave in Indonesia that was dated as 51,000 years old. Here's some other images from that cave, 45,000 years old, in a different portion of the cave. And here, the inhabitants of the cave left signs of their presence by making images of their hands on the walls, which I find really fascinating, just thinking of them doing that. Here's cave paintings from Piauí, Brazil, dated between 25 and 36,000 years. Here are cave paintings from Altamira Cave in Spain. Fantastic paintings with hands, part of a bull, some deer or antelope, and more hands. And look, we have a flying antelope. Here's a hunter with a flecha. And here's an arrow, you call it arrow flecha. Here's a beautiful bull. And notice the image of this bull in the cave, even this long ago, shows evidence of the painters painting three-dimensionality into the image. For example, you see that this left leg clearly appears to be in front of, closer to us than the other leg, because of the way he's made this shadowing. Same thing with the back legs. This leg appears to be in front of the other leg based on the very subtle lighting cues. And then there's the famous cave in Lascaux, France. And here's one image of many from that cave. Now we find these beautiful, but I wonder what the artist thought. Were these images art to them? Did they see them as beautiful? Were they just utilitarian? Perhaps preparation for or celebration of a hunt? Nevertheless, whatever they were, they have important implications because they show us that Homo sapiens has had throughout history very rich internal imagery and imagination, and a very strong urge to represent and communicate our internal images pictorially. It seems to be a universal and ancient in Homo sapiens, and maybe even in Neanderthals, because they did coexist for a time. So the topic of beauty and the brain historically has been a topic for philosophers and psychologists. But now we have a new robust science that is revealing the neural brain basis for human aesthetic experience, and this science is called neuroaesthetics. Neuroaesthetics has been defined by Raybrook and colleagues as the inquiry into the neurobiological basis of the aesthetic experience in general. And in fact, it's become such an important field of research that laboratories have appeared all around the world devoted to this topic. There's a famous one in Austria. There's one at the Max Planck Institute in Germany. There's a famous place in NYU devoted to this topic, and another one in the UK at Goldsmiths. One of our vision science colleagues, Samir Ziki, said that visual art obeys the laws of the visual brain and thus reveals these laws to us. A profound statement indeed. But the question is, what laws are revealed by art, and in what way? ¿Cómo se revela? This applies for all sense modalities, of course, but first we're going to talk about examples from the visual modality. Back at the beginning of the 20th century, the Gestalt psychologists spent a lot of time articulating and testing and examining what they developed into Gestalt laws of perception. And I'm only going to talk about a few of them. One of them is called the law of continuity or completion. That is, the visual brain fills in and completes occluded objects, which of course has obvious importance because everywhere you go, in every situation you find yourself, there are always objects that are occluding other objects. So it's a good thing. We don't need to see the whole object frequently to know what we're looking at. So for example, even though you can't see the occluded part of this wolf, your brain completes the wolf. Thank God, because at least you know it's only one wolf based on your knowledge of wolf anatomy. Now, another Gestalt topic is exploring the importance of our visual system being able to segregate figure from background in order to understand scenes. And I'm going to show you some examples where figure and background are ambiguous, deliberately ambiguous, to highlight how your brain is automatically attempting to come to a solution. But in these cases, it can't do it because they are ambiguous. So they are not stable. So you either see a vase or you see two faces looking at each other. And here's another example of that same kind of illusion. Here you see, if you focus on the black, you see the male legs. If you focus on the white, you see the female legs. You see either a saxophone player or a female face with lipstick. And scientists in our field actually have identified cells in a specific part of the brain labeled visual area 2 that seems to be involved in discriminating figure and background. Let's look at some examples from actual art where our understanding of space has been played with by the artist. The great surreal artist Rene Magritte did so in this painting, where he deliberately violates our brain's rules for understanding scenes. So here's the painting. We see a horse and a rider passing through some trees, but there's some strange things going on in this painting. He deliberately confuses our visual system's attempt to make complete sense out of this scene, which leads to some very interesting surreal effects. For example, I'll just talk about the individual surreal effects. How about this impossible tree I labeled number 3? If you follow along the forest floor here, tree 3 is clearly behind the other trees, and it's definitely far behind the horse and rider. But somehow, in the middle of the horse, somehow it ends up in front of the horse and rider, and then in the top of the scene, it recedes into the background again. So that ends up with having the effect that this strange tree appears convex because it's distant here, it's distant there, but it's closer to us. In this painted 3D scenario, it's closer to us in the middle. So the tree appears to be convex or slightly curved towards us, unlike all the other trees. And there's this weird impossible left rear leg. And we see it as impossible because it starts out behind the distant tree 3, but somehow winds between tree 3 and 1 and ends up in front of tree 3, in front of tree number 1, causing the leg to appear stretched and anatomically impossible, especially because he has created such a robust sense of space in the scene. And if you accept the spatial design of the scene, which our brain does automatically, it's not something you can change. The spatial design forces you to understand this leg as being distorted and stretched and probably impossibly long. And then the weirdest part, the most surreal part of the painting is this section where the horse appears to be the horse, and the reins and the left hand of the rider appear to be blocked by what should be open space or background. We see it as background down on the bottom. We see it as background up at the top. But in the middle, it appears, at least temporarily, as if it were an occluding ribbon of some sort that's blocking the horse and the rider's left hand and the reins. So you have this, in the middle portion, you have this figure and ground reversal. If it's blocking the horse, it's perceived as foreground or figure. If you see it as background, then of course it's reversed its location in 3D space. And most of the time, at least for me, I see the horse as complete, because your brain, object integrity seems to be one of the rules of the brain, to maintain object integrity even when things are occluded. Like, for example, we assume that there's a horse behind this tree, even though the tree here is also breaks the horse's integrity visually. So visual completion of the horse by the brain forces us to then see this section as an opaque, occluding ribbon, at least temporarily, until you flip perspective. And you can see that all these surreal effects are controlled entirely by our understanding of space that Magritte has designed here, if you take away all of the background and just have the horse and rider. And now in this scene, where we've done that, you can see that even this left rear leg does not appear to be stretched or too long. It just appears to be blocked by some unseen object here in the dark. But it appears to be a normal size, and it doesn't appear to be bent or winding. And this appears to be a complete horse, just occluded by some unknown object in the dark. So it was the 3D scene in which the horse and rider were placed that created the distortions that we saw. Now, you know that 3D perception has to be generated by your brain, because what falls on your retina, first of all, your retina has all the receptors that capture photons and then eventually send signals to the brain that we end up seeing as visual scenes. But the retina itself is a two-dimensional sheet of cells. There's no 3D on the retina, on the receptors. The brain has to create the third dimension from the signals coming from that two-dimensional array of light and dark activating receptors in our retina. Now, there's many cues that can give us information about depth and distance, and even 3D structure of objects. And one important visual cue are shadows. Shadows give us a lot of information about implied lighting sources, and they can give 2D painting or 2D painted objects perceived three-dimensionality, which is, any good artist knows this. In fact, we would have seen these trees as flat if Magritte hadn't put shadows on the trees. So their importance can be emphasized, the importance of shadows, by some provocative perceptual failures, which are known as illusions. So here's an example. This is a photo that I took in Brazil, in Sao Paulo, when I was working at the university at the Laboratório da Visão. I took the photo of this ant hill or ant structure, and you can see that you can see that the light source is coming from the upper right based on this shadow, and the fact that the sand here, the hill, is a little bit shadowed compared to this part of the structure. So imagine that you were an ant. You come out of the nest, you climb up the little hill, then you go down a very steep, straight, vertical structure, and then you walk along the sidewalk between the leaves of grass. Now watch what happens when I turn this image upside down. Now, the source of lighting appears to be coming from here. Imagine you're an ant walking along the sidewalk. You have to go back home. You climb down a steep structure, and then you climb up a little hill, and then go into the center of the cone, into your nest. But of course, this is not reality. We know that the light source was coming from down here, not up here. So your brain had to make an assumption about the source of light based on the information it had, which was the shadows. But the brain has no way of knowing that, except that I know what I did with the photo. I turned it upside down. And so it has fooled your visual system into thinking that the light source is coming from near the grass instead of on the opposite corner. And that has caused a reversal and an ambiguity in your understanding of the 3D structure of this ant hill or ant structure. The same thing occurs in this photo that I took of the mosaic at Parc Güell in Barcelona. So you can see that what we have here are 5 concave sections in the mosaic, and we have 4 convex bumps. You see, these are bumps facing out towards you. But when I turn this image upside down, they all reverse. Whoops, they all reverse. Now, the bumps are now indentations, concave, and the indentations now appear to be convex. These now look like bumps bulging out towards you. I took this photo at a museum in South Florida, and when I show this to people, they are usually confused. They don't know what they're looking at. They say, well, I don't know. What is that? Is that a mouth? And are these eyes? They get very confused. And then I show them this image in its correct orientation, shown here. And now they go, oh, meu Deus, agora vejo. So you see your brain, the 3D structure of this lower portion of the face was completely confused when we viewed it upside down, because your brain interpreted the shadow information incorrectly. There's the original sculpture. It even happens in dynamic images. For example, watch the ball and its trajectory in 3-dimensional space. Meu Deus. So you see the ball appears to be going up and down in space above the xadrez, and it's traveling parallel to the front row of squares, almost parallel. It's going up, and then it comes back down. Now it appears to be rolling along the diagonal of the xadrez, but on the surface of the xadrez. Concorda? Concordan? Well, in fact, now watch what happens now. If you take away the shadow, now you can see it either way if you want. Like if you want to see it as going up and down along the front row, you can see it that way. Or if you decide it's rolling along the diagonal on the surface of the xadrez, you can see it that way. So the entire 3-dimensional interpretation of what was going on in that dynamic scene was created by the shadow itself. The ball was doing the same thing in each one of those little mini video clips. Now we know that understanding objects and scenes is highly dependent on context. And an example is shown here by a colleague of mine, Edward Adelson. He drew this checkerboard and the cylinder in one of his drawing programs, and he painted in an apparent shadow on the cylinder and on the xadrez. And based on the way he depicted the shadow, he's telling us that the light is coming from above and to the right. And now if I ask you, is this cuadrado B mais brillante de cuadrado A? Almost everyone will say, well, of course, cuadrado B é mais brillante, mais luminoso. In fact, they're identical. So I constructed these two squares in PowerPoint, and I'm just going to slide them over Adelson's painting, and you'll see that even though they do not change physically, perceptually, they change. Here they come. Ba-bam. Legal, ne? Cool, huh? Here, same thing. The dark diamonds here are in fact the same brightness, the same physical amount of light is coming off of these diamonds as these diamonds, but they don't look that way at all. But they are identical. All I did was change their context. Context, even of course, is critical for understanding perceived size and distance. So for example, we see a man standing quite a bit behind this woman in a hallway. But if we just artificially bring the man to appear next to her, he seems like a tiny midget. But it's all because of the effect of your understanding of distance. So let's talk a little bit about our topic of today, beauty and the aesthetic experience itself. And I'm going to start out by showing you or illustrating for you that even in the world of art, beauty does not need to be associated with objects or things. A beleza não deve ser associada a coisas, objetos. So let's consider the aesthetics of abstract art for the moment. So do you find, just think about this for a moment, do you find these paintings to be beautiful, these abstract paintings to be beautiful? Maybe one more than another. What about these abstract paintings? Do you find these to be beautiful? How about these abstract paintings? How about these two abstract paintings? And these paintings and collages, which I love these, by the way. I hope you do. Well, I'm going to reveal to you the artists who made all of these images. Oh no, well, after this one. So do you find, not all art has to be beautiful to have an extreme impact on us. For example, these all have a very strong impact, but they may not be seen as beautiful, but they are certainly powerful images. So now I'm going to reveal to you who made all these images. These were all made by Gorilla, every one of them. Michael made 3 of them and Coco made 1. These were all made by humans. These 2 by Vasily Kandinsky in the early 20th century. And these were made by recent abstract artists who I'm not familiar with, Emma and Gina. These were made by my son. This is a painting by Morgan Russell, and this is an image of color-coded or cortical orientation columns in primate cortex anatomy. This is a detail from one of Monet's paintings called The Garden. And this is a close-up of visualized connective tissue cells co-transduced. Biology again. These are all paintings and collages done by children in a special school in Sao Paulo, and all these children had severe spastic cerebral palsy. And they did all of these, which I think are amazing personally. And they also did these two on the right, which are imitations of Basquiat, the actual artist Basquiat. And here are the students at that school who painted their own faces and then pasted them on this collage for us to see. Now we know that perception is the net result of many processing by many specialized interacting brain modules or sections of the brain. And you don't have to know the details of what I'm showing you here. This is just to illustrate that when signals come from the eye and end up in the back of the head where actual conscious vision begins in the visual area 1, from there, signals are then processed further by many other specialized regions that are color-coded here. So just to pick some of them, the brain seems to segregate figure from background in area V2, which is here, this orange. Visual texture in the medial occipital cortex. Face recognition in the fusiform face area down below the temporal lobe here. Scene recognition in this area of the brain, which happens to also be in the temporal lobe. Cognitive aspects in the prefrontal cortex. Object recognition in the lateral occipital cortex and the inferior temporal cortex and in the frontal lobes, just as an example of the specializations. So the questions arise, how is the aesthetic experience represented in the brain? Is there a single beauty module, or are there many? Let's consider one aspect that's often associated with beauty, that is symmetry. We know from many psychophysical studies that people prefer symmetrical patterns over asymmetrical patterns, even when they're just basic, simple, abstract designs like this. We know that if you take a human face, female face, for example, and you average, in this case, 15 average-looking women's faces, the net result of the average is a female face who is preferred aesthetically to all of the individual component faces, but she also happens to have more actual physical symmetry than any of the contributing faces that were averaged. We know the importance of symmetry by just looking at human architecture. And we know about the importance of symmetry in the way that we perceive and are affected by symmetry in nature. And this is a design I constructed with a set of diatom frustrules reflected. And here's something I constructed from individual brain corals. And now the pattern, the symmetrical pattern, is very interesting and attractive, at least to me. I constructed this from reproducing Drosophila instars. So again, here's biology. 1, 2, 3, 4, 5, 6 of them. Put them together and you have this very interesting symmetrical pattern. These are 12 reproductions of mouse organ of Corti, that is where they hear, inside the inner ear. Here's one of them. Here's another one. Here's it's pairs, and here's another one, and so on. If I show you this snake, some of you might find the pattern on the snake beautiful, but this image itself might not be very appealing, but suddenly it becomes a little more beautiful when I make it into a symmetrical reproduction of the snake, this way, or even this way, or this way, or this way. And in psychophysical tests, a scientist named Leder and colleagues found that non-art experts strongly prefer complex symmetrical stimuli and see them as most beautiful. And that's this bar here. Now, symmetry is important in part because it's built into your brain detection mechanisms. Each of us, every one of you, are virtuoso symmetry detectors. So a study done by my colleague in San Francisco, Christopher Tyler, examined how fast can humans perceive symmetry, even in what appear to be completely random dots, array of random dots on a screen. So what he did was he would present to subjects a screen like this in 2 time intervals. In one of the time intervals, he constructed artificially, he made sure that the left and right parts of the screen were in fact mirror images of the random dots. And in those, so for example, in this example, you can sort of see a circular pattern here, and then you see it also on this side. And so there's lots of little symmetrical elements in this. The arrows simply mark a region where he made sure everything was completely random. And then he varied the distance between, he varied the amount of the screen area that was completely random. And he would then also vary the duration of the presentation and ask subjects to decide. Every time he presented 2 trials, he would say, okay, in which interval did you see as symmetric? And in fact, the symmetry would only occur in one of the 2 intervals randomly, but they had to make a guess. And so what happened was he could form what's called a psychometric function. That is, if they made a completely random guess, since they had only 2 options, either interval 1 or interval 2, by chance, they would perform at 50% correct. If they were correct on every single trial, they would be at 100% correct. So as he varied duration, the percent correct went up as the duration got longer, and they decided that the threshold was where performance would achieve 75% correct. And that happened to occur when the stimulus was only 40 milliseconds long. That's 4/10 of 100 milliseconds, 4/10 of a tenth of a second. And you could already reliably detect symmetry in something this random, if you can believe that. So the brain is incredible in doing this. Another group of scientists studied symmetry by examining actual responses in human brains by presenting them with patterns that were either deliberately symmetric or deliberately random. And they presented many, many trials while measuring the brain response in the imaging machine. And at the end, they would subtract the parts of the brain that seemed to be activated by the random stimulus, and they would subtract all of that information from the parts that were activated when the symmetric stimuli were presented. And the result, what was remaining, was response specifically to some symmetry. And they found that only very specific regions seemed to be activated by these symmetrical patterns, and they were labeled these areas. You don't have to know what these mean, but to people in our field, they know that these are visual area 3, anterior, visual 4, ventral, visual 4, dorsal, V7, and lateral occipital, and so on. Now, of course, beauty is associated with pleasure, intuitively and experientially. So another imaging study asked the question, well, what parts of the brain are activated when subjects are viewing faces that they judge to be attractive or beautiful? Well, it turned out that for the attractive faces, these centers were activated, which happens to be in the region of the nucleus accumbens, which is the part of the brain that's in our reward processing centers, that generates endorphins and dopa and all of the happy hormones that lead to pleasure. The ugly faces that the subjects chose as ugly in the imaging study seem to activate more the amygdala, which is associated with negative emotions. So again, here's another hint of localization of beauty responses in the brain. So there are many, many theories of how beauty, how we process beauty, what constitutes beauty. And no tenho tempo hoje para mergulhar en cada hipótesis individualmente, but I want to summarize some of them for you. So for example, starting way back with Immanuel Kant and then later Fechner, the father of psychophysics, and more recently, people like Brilman and Dennis Pelly, they all focus very strongly on the importance of linking beauty with pleasure itself, that it requires pleasure. Beauty is often related to information content or reduction of entropy in the brain. This is a study done by one of my colleagues at Smith-Kettlewell, who's now at Loyola, Norberto Grivax, who, by the way, is from Sao Paulo, speaks Portuguese, speaks Hebrew, speaks Spanish, and speaks English fluently, all of them. There are fluency models by Reber and colleagues, which they claim that things that are seen as beautiful are associated with things that are easily processed by the brain, what he calls neural fluency. There's the cognitive mastery model of Leder and colleagues, that is, beauty also requires some sort of understanding of what you're looking at. I find that to be a priori an inadequate model, but like I said, I don't have time to go into depth here. There's a very well-known two-stage model of Locher et al., and I like the flavor of this model. They say that we quickly extract the gist of a scene, meaning your first impression, and after that comes a very slow cognitive, evaluative, and even emotional stage, which makes it's kind of common sense to me. And then there's Chatterjee's three-stage model. You have sensory motor processing, then which leads to some sort of knowledge meaning extraction, which then is linked to generation of emotion and valuation, positive feelings. And there are others much more complicated than this. But getting back to imaging, let's talk about that, because it's a little more concrete here. For example, Edward Vessel and his colleagues have done a number of studies that show that a part of the brain that is usually associated with daydreaming, meaning that it's usually inactive when we're doing any kind of tarefa, any task. And that's highlighted in yellow here. It's called the default mode network. Normally, it's silent when you're daydreaming, when you're doing tasks, tarefas. But when you're daydreaming, just sitting and thinking and imagining things, it's very active. But in this study, they presented subjects with a series of paintings that they had to judge whether they were beautiful, ugly, and anything in between on a 10-point scale. And for the images that were judged to be beautiful by these subjects, suddenly a part of the brain was activated that normally would be associated with the default mode network, which is normally silent when you're doing a task. But in the case of beauty judgments, it was activated. And that's reproduced in this slide also. Here is a blown up version of an imaged brain, and these color regions are part of the default mode network, just visualized in a different way in this figure. Now, that was done in 2019. In a little older study by Semir Zeki and his colleague Ishizu, they presented subjects with a series of paintings that they had to judge for aesthetic appeal, from ugly to beautiful and everything in between. And they did the same thing for samples of music. And then they repeated the study while they were imaging the brains, and they looked to see what parts of the brain were activated by when beautiful paintings were being seen or beautiful sections of music were being listened to. So the portions that lit up in red were responding to beautiful visuals. The portions in green were responding to beautiful auditory stimuli, and the portions in yellow were responding to both. And these happen to occur in a part of the brain called the medial orbital frontal cortex. It's called MOFC, medial orbital frontal cortex. Remember that name only because it's going to show up in the next slides in a very unusual, surprising context. Now, the importance, and in fact, it shows up even when you measure mathematical beauty in subjects. Let's talk about the importance of mathematical beauty. Way back in the time of Plato and Aristotle, mathematical beauty was recognized. Mathematical beauty is the highest form of beauty, Plato said. It's the most abstract of emotional experiences. And Aristotle said that it's one of the chief forms of beauty based on order, symmetry, and definiteness, which the mathematical sciences demonstrate in a special degree. So Aristotle recognized the association of beauty with mathematics, and the more modern philosopher Bertrand Russell did also. The true spirit of delight, the exaltation, the sense of being more than man, which is the touchstone of the highest excellence, is to be found in mathematics as surely as poetry. So Ziki did a study with 15 highly experienced young mathematicians, and they were asked to rate 60 equations on a beauty scale from ugly, -5, to +5, beautiful. And they showed them these equations many times. So here's examples of a beautiful, simple equation and an ugly, complex equation. And then they did an imaging study, and they took a sample of a set of ugly equations that the subjects had judged ugly, and they took another set of equations that the mathematicians judged as beautiful, and then they took another equal number of samples from all of the equations in the middle that were judged as somewhere between beautiful and ugly. And then they did the imaging study. So the subjects in the imaging machine were shown an equation for 16 seconds. And then after a delay, they had to push a button and say whether it was beautiful, neutral, or ugly. And then they tabulate all the results to see what parts of the brain were activated for equations that were beautiful, that were judged to be beautiful, experienced as beautiful. Guess what? The medial orbital frontal cortex was activated in these mathematicians when they viewed beautiful equations. That's the same region that was activated in Ziki's earlier study with auditory and visual stimuli. So it's starting to seem like we're beginning to perhaps find a generalized beauty module or in the brain, or at least there's a couple of very good candidates for this, at least. Now, one of my colleagues in Canada has proposed an evolutionary approach. Of course, any evolutionary approach makes a lot of common sense if you believe in biology at all. That is, our ability to perceive beauty and the fact that we make art and that we even are talking about beauty must have its basis in some sense in our evolution as sapient cognitive performing Homo sapiens. But he says that he thinks that our aesthetic responses first evolved for appraisal of objects in terms of their survival advantage. But then later were taken over, what he calls co-opted, in humans for the experience of artworks, for example, for the satisfaction of social needs. Now, there's something very commonsensical about this, but I also think it's very inadequate for the broader aesthetic experience that we all can talk about. You know, using an evolutionary approach, you need to be able to explain things more complicated than this, like a symphony or a poem or completely free jazz or cool jazz. Why do people play football? What about ballet or aesthetic responses to math itself? What about art that isn't experienced as beautiful, but ugly or meaningful and symbolic in some other way? So I think this is an important starting point to pay attention to the importance of an evolutionary perspective. But I think it's not adequate to explain the many-dimensional features of our aesthetic experience. Brielman and Pelley proposed that beauty requires pleasure. And they studied almost 800 participants, showing them and asking them how strongly they felt beauty, viewing 900 images, none of which were art. And they conclude that our findings support the idea that intense beauty requires, note the word requires, intense pleasure. So my question is, are the mechanisms underlying beauty and pleasure distinct, or are they just different strengths of the same neural mechanisms? My idea, their idea is that beauty and pleasure are merely two judgments based on the same hedonic intensity. Hedonic intensity perhaps meaning the amount of dopamine or endorphins released in the presence of these stimuli, but they only differ in their thresholds, how strongly they have to be activated to experience beauty instead of simple pleasure or liking. And they propose that the threshold for the beautiful is a higher threshold than the threshold for liking things or mere pleasure, sensory pleasure. But I find even this to be a wholly inadequate theory. Because for one thing, we know that even ugly, chaotic, abstract art can be aesthetically or emotionally or intellectually impactful, meaning it has a strong effect on us. For example, Basquiat, we saw earlier, many people might not call this beautiful, but they often will say that it has a powerful effect on them anyway. The famous painting of Picasso, Guernica, which is a painting about war, has a very powerful emotional impact, but it may not be perceived as beautiful because there's a lot of unpleasant imagery in this painting: suffering, angst, pleading, pain, gritas. This is not a soft, easy, harmonious, pleasant painting, but it's a very powerfully impactful painting. Another example is any paintings by Jackson Pollock. Now, I have a colleague who told me that some of Jackson Pollock's paintings make him cry. They have no effect on me that way. I find them impressive, but not emotional like that. This is a 1952 work by Pollock. Here's a very interesting finding. That is, creative artistic expression appears to have a very strong basis in multimodal processing. For example, Kandinsky's composition number 5 was inspired after he went to a concert by Arnold Schoenberg playing, the musicians playing Schoenberg's second string quartet. Nossa Senora. Well, the auditory is not playing. I had some audio here. Look up this string quartet. It's very interesting. It's kind of abstract. I find it beautiful. So when it's a 12-tone piece, it's not in any particular musical key. And when Schoenberg came out of the concert, he realized, he said to himself, my God, if Schoenberg can create that without being restricted to composing in any particular musical key, then I don't have to paint things anymore. I can paint anything I want. And then and there was born composition number 5 that we see here. Now some of you may know about Mark Rothko's work. I find his work to be interesting, but I don't have an emotional response to his work, even though I like his work. Here are 2 examples. But it turns out Rothko said he wanted to make his paintings in a way that would bring people to tears, to make them cry. And in fact, he succeeded. Because in Houston, Texas, there is a place called the Rothko Chapel. And in that chapel, they have many of his paintings, but they also have counselors, psicólogos, to go around and help people who start crying in the chapel, which I find to be incredible, but it's true. In fact, an art historian had a very emotional reaction to Rothko, and he cries when he sees some Rothko paintings. And I want to read this to you, read everything he wrote about this, because I think it's beautiful writing, and it gives an insight into the way in which Rothko reached the emotions of this man and perhaps many others. He writes, "It is my experience of being with a Rothko and being in love equally. I fall into the space opened for me by the canvas, and again by the infinite depths of color within color, just as I fall into someone I love. Recognizing the discomfort of this intimacy, with nothing between me and the canvas, nothing between me and another's soul, I recoil, I pull back, and in this falling, I am moved to tears. Rothko's paintings offer me a space of perfect stillness, a space that brings me face to face with nothing other than the power of who I am. His paintings show me the stillness, thus the life inside of me, and it is a stillness so naked that there is nowhere to go but to tears." Now that is some beautiful writing, my friends. Now, I claim that our language gives us a clue that beauty cannot be carried by the same neural mechanisms as our experience of, let's say, the pleasures of food or a back rub. And my reasoning is that we use very different kinds of language in the 2 situations. And I'm going to show you a list. They'll appear to be paired left and right, but they're not. It's just a vertical list of language used for food and ordinary sensory pleasures. And on the right, you'll see a list, growing list, of words that we tend to use for art and scenes and faces and even ideas. And I have them translated into Portuguese words as best I can. So I'll just show these to you one after the other. Gostoso on the left, linda on the right, cremoso, like quindim, serene, serena, fragrant perfume, colorful scene, colorful flower, colorful painting. Sweet, doce, luminous, luminosa, radiante, or loud on the left, dissonant on the left, dissonante, esplendida. So you can see, I'm going to go through the list here. If you look down the list, you'll see that generally the list on the right you wouldn't use for ordinary sensations in either gustation or audition, hearing, or vision, or touch. But the words on the left are much more associated with our ordinary sensory pleasures or displeasures. And there's a huge list of these. The reason I think that our choice of different language, different words for the different situations is important is the following. I did my first postdoc with Davida Teller in Seattle, Washington. And in a 1984 paper, she wrote about a paper called Linking Hypotheses. She writes this sentence: discriminable sensations imply discriminable physiological states. So if you believe that all of experience is actually carried by the activity of neurons and hormones in the brain, this is a very strong statement. If you can discriminate any two sensations, it must be the case. It implies that different physiological things were happening inside of you in order for you to be able to make that discrimination. That's the logic of this sentence or this statement. And we know that we use, as I just showed you, different language for beauty and aesthetic experiences versus ordinary pleasures. And this, to me, implies that distinct brain mechanisms are associated with aesthetic talk versus ordinary sensory talk. And my hypothesis is that beauty and ordinary sensory hedonic pleasures activate some of the same neural substrate. What's activated in us overlaps. It makes sense that it would overlap because we do experience pleasure in many situations where we also experience beauty. But based on the language argument that I just gave you, that these two are not identical. I argue that aesthetic beauty must activate some distinct brain mechanisms. And thus, the Venn diagrams, if we could draw them, if we knew how to draw them, would overlap, surely, but would have some areas in which that were distinct in different parts of the brain. And thus I conclude that the answer to my original question, the title of this talk, is definitely, or my hypothesis is no. Da Vinci's Mona Lisa is not just another kind of visual chocolate. So look at Mona Lisa's face right now. Veja. Muito obrigado, gente. That's my talk.
Russell, muito obrigado. Incrível palestra.
Obrigado.
Incrível.
Obrigado, José. I'm sorry if I went too long.
No,
I don't know how long.
Uma palestra muito interessante, muito bonita. Tá? Muito bonita.
And I hope stimulating, intellectually stimulating, because
claro, com certeza.
The topic of beauty it goes to the coração of what makes us unique humans, Right?
Sim, claro. Eu vou te iniciar com algumas perguntas. Can you understand me in Portuguese?
Devagar um pouco. Go ahead.
Ok.
Devagar.
Eu vou começar com algumas perguntas do pessoal do chat.
Ok.
Tá? Então, tem várias aqui que... O Jaderson, ele perguntou se seria correto afirmar que a orientação sexual produziria um viés, né, um bias, para ver as pernas de homens e mulheres. Do you remember in the beginning of your presentation
I
there
remember,
was a slide?
Lembro.
Yeah.
Let me read the translation here.
Okay.
From the point of view of it's correct to affirm the human genre of sexual orientation will produce biases. Yeah, that's true. Bias could. Can I speak in English?
Yeah. You choose. You choose.
Recordo que bias, preconceitos pode afetar percepção. And the caso that, for example, the example you bring of the legs, in that image. And of course, it's just an average that on average we often see in the past and sometimes now, but more in the past, men wearing certain kinds of shoes and pants, women wearing others. There's no statement about, there was nothing important there intended. I did not intend to say anything important about norms related to sexuality, orientation, or gender. It's just that I could have shown the same images in a different way. I picked an example that happens to be very commonly presented in many talks about figure and background, but there's no sexual politics involved in that slide whatsoever. No, nothing intended.
Okay. I have one more question. I think this question of Mauricio is also about the figure background slides you show. He asking about why the black and white image differently when they appear to be two forms at once. So
he says, does the moment change what we see? I'm not, the second part of his question, I don't no entiendo. He has to explain that.
Okay. I don't know this. I think he forgot something in the second part, but in the first part.
I think this is a translation problem from his head
Yeah.
to English. I think what he means is, what is causing the bistability? Why do you see it one way at one moment and another way at another moment? And,
the saxophone guy and after the girl. Yeah, and you change.
The fact that it's, I hope he understands me in English. The fact that it is bistable, that you can see it one way or another way, is a way of showing us your brain actively trying to make sense out of a scene and trying to establish a figure and background that's stable. But in these artificial drawings, they were drawn to be unstable, to cause an unstable figure ground segregation. It's, in a way, it shows us our brain trying to solve a problem that frequently we don't encounter this problem in the normal environment. It's only in these artificial images that we have unstable figure and background. If we had that happen a lot walking around in the world, we'd be in trouble.
Obrigatoriamente, o cérebro faz isso com os mesmos neurônios? O neurônio que enxerga o saxofonista seria os mesmos que estão querendo enxergar o rosto da moça?
Well, that's a good question. So let's say that area V2 helps you decide what's figure and what's background. But of course, when you move your eye to a different part of that image, you're moving all those receptive fields to a different part, which can change the polarity, and suddenly you see figure instead of background. But this also, it's very clear that this also has to be in part processed at higher levels, because you have to have memory recognition of what a saxophone looks like. You have to have a memory recognition of what a face looks like. And so it can't all be early areas in visual cortex 2. It has to bring in inferotemporal cortex and your knowledge of objects in order to have this bistable flipping occur.
Yeah. We have a question from Cecilia about
Porque algumas pessoas não conseguem ver nenhuma beleza em equações matemáticas. Like me. Well, Cecília, o estudo, a pesquisa que discuti, nesta pesquisa, they chose, how do you say they chose? Escolheram pessoas bem com muita experiência em matemática, expertos em matemática, people who studied mathematics, who love mathematics, who were knowledgeable. And you know, the scientists who did that study, they not only did they ask them to evaluate the beauty of the equation, they also tested them how much they understood each equation. So if they didn't understand the equation, they couldn't be used in this experiment. So only if they saw it as beautiful and they understood the equation, the significance of the equation. Now, for us who don't know math that well, even if you saw something that was visually symmetrical, that you found sort of visually appealing, if you don't know math very well, that doesn't mean you're going to find it conceptually beautiful.
Yeah.
Again,
Russell, pode falar.
Again, it means that the beauty experience there relies heavily on our cognitive, intellectual experience that's also connected to the symbols we're seeing in front of us. These little symbols of black and white on white paper signify something that we understand cognitively in a very abstract way. And nevertheless, it activates parts of the brain that seem to be activated by very simple sensory things perceived as beautiful.
Russell, é uma questão minha, na verdade, essa daqui. A beleza, vamos dizer assim, acho que foi a Simone que terminou fazendo um comentário, eu vou aproveitar o comentário dela. Ela realmente está nos olhos de quem vê, vamos dizer assim. O estímulo está lá fora e a gente tem a sensação da beleza após interpretar aquilo. Mas é possível a gente dividir a experiência da sensação da beleza em... Por exemplo, você falou alguma coisa sobre a pessoa ter um forte caráter emocional, mas antes disso ela tem que ter uma detecção de alguma coisa. É possível, cientificamente, de você separar em partes a experiência de sentir a beleza? Ou, por ter várias belezas, não é possível?
Well, maybe, for example, if you had subjects, can you leave her comments up? I want to see her comments again.
Okay.
In answer to Simone, we don't see with the eyes, we see with the brain. That's the fundamental answer. We do not see with the eyes. There is no vision or what you experience as perception in the eyes. That all happens in the brain. However, obviously, you need the information coming from the retina going to the brain in order for us to experience visual beauty. And when and where and what parts of our physiological response does beauty happen, that's exactly the problem that we're trying to solve in these experiments I've been talking about. When you look at a painting and you see one part of it is red and another part is blue, another part is green, I take it from your question that you're probably an artist or interested in art. I'm going to tell you right now that color does not happen. There is no color in the world. It's all in your brain. I don't want to shock you, but in answer to Zhivago's question, for example, if we showed subjects images and what we tried to do was find ask them to press a button. This is a very crude experiment. Press the button the minute you have an aesthetic response to this, whether you decide it's beautiful or ugly, finding out when does the experience of beauty occur. Or you could measure eye movements and find out how many eye movements gazing at a scene does it take before the subject starts to experience beauty. It's a very difficult question. Clearly, it requires processing. Clearly, it's not in the peripheral image coming in the early stages of vision or hearing or touch. And in the case of mathematics, it's all in the head. If you were a professional dancer, I've spent a lot of my life dancing, and I can say that I had moments dancing in which I experienced ecstatic beauty dancing, but it's a completely internal experience. Maybe you would have watched me and said, "Oh boy, is that ugly." I doubt it. I'm a good dancer, but yeah, there is beauty internally when you're actually doing activities like dance or playing a musical instrument.
Mas nem sempre tem uma carga emocional na beleza. Ou sempre tem uma carga emocional.
Is your question, is there always an emotional reaction with beauty?
Yes. Emotional load in the experience of beauty.
Well, a lot of studies claim there is, but I gave some examples where beauty starts to get confused or with things of different kinds of important experiences, like the cognitive impact of a painting like Guernica by Picasso, which I showed depicts elements of the scenes or elements from Guerra. So they're very difficult experiences that depict pain and suffering and anguish. But you might find the design of the painting to be a beautiful, balanced design. But that's a different level of analysis inside of our heads. So I think that beauty is more complicated than simple pleasure. And I think the mathematical beauty is a perfect example that it cannot be summarized with simple sensory input.
Professor José Aparecido, por favor, o Russell está pedindo a sua pergunta. Já que equações matemáticas não são bonitas por si próprias, tem um componente cognitivo aí por trás.
Sim, é verdade, é verdade. Eu particularmente gosto de números, você sabe muito bem. Sou um tirano, não é, por usar números em pesquisa. Primeiramente, quero agradecer o professor Russell pela excelente palestra, magnífica. Eu, particularmente, gosto muito dessa ideia de investigar fenômenos complexos, como diria o Fechner, ou estudar a estética do ponto de vista experimental. Meus cumprimentos pela magnífica palestra.
Obrigado.
Eu adorei as figuras.
Obrigado.
Como um perceptólogo apaixonado por percepção do espaço, sobre a qual eu dediquei, você sabe, Zhivago sabe, quase 40 anos da minha vida, e eu tenho uma paixão especial pela ilusão da lua, Moon Illusion. Eu sou realmente apaixonado por esse fenômeno natural. Então, parabéns. A minha pergunta, para simplificar, how about the monocular and binocular cues on perception of artistic picture?
Well, for example, the Magritte painting I showed you had very profound implied three-dimensionality in the painting. Concorda?
Sim, sim.
But of course, it's a two-dimensional painting, and so stereopsis, using two eyes, would not help you. No, you have no advantage using two eyes over one eye viewing a two-dimensional painting.
For example, in that picture of the horse, the compression of size, I ask myself, how about the importance or the value, the valor, the familiar size? I know horse has a normal size, usually.
Exactly.
How about the effect of familiar size?
Yes.
The size of the horse, of the size of the moon, or
yes, well,
the people, the size of the people.
That's what I was saying about Magritte's painting. For example, that left rear leg of the horse, it would not look strange if you had no knowledge of what a normal horse leg is, right? You would have no reason to question it if you didn't have that knowledge. And not only that, as I showed you in the slide where I eliminated the background, the leg suddenly appeared normal length, and it did not appear twisted as it did in the original painting. And that was completely induced by the context of the leg, around the leg. So you had cognitive influences there affecting your understanding of structure that you were looking at.
Yeah.
And all of the effects, the surreal effects, were generated by your understanding of space in 3 dimensions that he generated in his expert depiction of space. All of the cues for distance, texture gradients, atmospheric haze, linear perspective, size, and all of the different cues that we use to understand space and distance he had in that painting. And then he went and he's a travieso. He's messed with your head to distort your understanding of certain elements in the scene.
Eu tenho uma outra. O senhor quer continuar, professor José Aparecido?
Não, estou agradecendo. Tá. Muito obrigado. Muito obrigado.
Eu tenho uma outra pergunta para o Russell, que é de tempos em tempos surge um artista com uma coisa totalmente nova, assim como um dia o Picasso e o Salvador Dalí surgiram com imagens totalmente bizarras, e isso trouxe beleza a gente, né? A experiência estética existiu em cima de uma coisa que não existia antes. Eu pergunto para o Russell se existe limite para a gente perceber beleza, já que parece que o que o ser humano faz, uma vez que tenha significado, gera na gente essa sensação de que é belo, vamos dizer assim.
Okay, I think the nature of your question is how much our experience determines the things that we can accept as beautiful. Is that right?
Yeah.
Well, if I'm understanding your question correctly, my comment is that, we have many examples that in humanity that I'll talk about. Tell me if you like this concept, Zhivago. The aesthetic bandwidth, right? What you can accept as beautiful. And here's a wonderful example. In 1913, the Stravinsky's Sacre du Printemps debuted in a theater in Paris. And after the curtain opened and the orchestra started to play and the dancers came on stage, within about 15 seconds, people were throwing things on stage, fighting in the audience, screaming and yelling. There was a complete riot in the audience when the Rites of Spring started playing. Nowadays, the Rites of Spring is thought to be one of the most important, beautiful pieces of music ever composed. So what I'm saying is that our aesthetic bandwidth can be shifted. You know, your window of acceptance angle for beauty can shift. For example, the more I learned about jazz, the weirder jazz I could accept as interesting or beautiful. Initially, I couldn't listen to John Coltrane. But then eventually I got to love John Coltrane as I understood the inside of the music better. My understanding of choro changed while I lived in Brazil. When I got to watch these incredible musicians make choro music right there in a bar in front of me. And I suddenly realized how much musical knowledge they had in their heads. And I appreciated the music all the more. Taste. I used to hate the taste of cilantro. How do you say cilantro?
Cilantro.
Cilantro. Oh, wait. Okay, Google. Translate cilantro into Portuguese.
Coentro.
Yeah, coentro. I couldn't eat coentro. If I tasted coentro, I would get nausea. I would get vomite.
Ah, mano, caramba.
But then I moved to California, where there's many people from Central and South America, and Mexican food. They use a lot of cilantro, coentro. And I came to love coentro. Now I love coentro. You know, so the general point is our aesthetic bandwidth changes with experience and understanding.
Yeah. Russell, eu tenho outra pergunta.
Esther. I'm going to read it. Pessoas com noção de arte e estética são mais exigentes para você. So exigentes meaning they're more attentive to beauty. They pay more attention to beauty.
I think it is.
Knowledge about the arts and the aesthetics.
Yeah, but exigentes, that meaning they pay more attention.
Exigente, the beauty should be very much beauty to be considered as beauty.
Oh, so the idea is can people pessoas com noção de arte, that is people like artists.
No, people like art.
So they have more of an understanding and of beauty, and are they able to observe things that other people cannot see? That's what she's saying. Conseguem observar coisas que outros não veem. Is it right?
Yeah.
The answer is yes and no, in my opinion. The answer is no on a fundamental sensory level. You know, as long as you have a normal visual system, we all are able to see the same things getting into the brain from the eye. The no answer is that what you see and its effect on you emotionally does depend on your experience with art, or the creation of art, or the study of art, or going to lots of museums. So the answer is yes. And I think even in my talk today, I showed some examples where art, like for example, the change in Kandinsky, simply after hearing a certain piece of music, he realized that a whole other world of beauty and art opened up in his mind. But is he capable of understanding differential equations better? I don't think so. Is he capable of being a better chef or a better dancer? I doubt it. Those are different skills.
Okay. There is a question about
wait, I have one more thing to answer her.
Okay.
Something very important that you direct my attention to is that, yes, the more you know about beauty and art, you are able to make more intellectual analogies that perhaps you can find in your own life apply in many other situations. And someone who pays no attention to art or symmetry or any of the elements of beauty might not notice the things that you notice. And I know this is true because many times I go out walking with a friend and I'll say, okay, look at the leaf on that plant. You notice that leaf is asymmetrical? Wow. Do you know how rare that is in nature? You almost never see leaves that are asymmetrical. They're always symmetrical. And I had a friend I was walking with, and she said, so what? Who cares?
Yeah.
But to me, it meant something about evolution. To her, it meant nothing.
Great. Next question. We are going to the end of the talk. Here, F asked you, and how about I think is golden proportion? Is something like this?
Yeah, the golden proportion has been studied, but see, there's a difference in the studies of beauty. Some studies and theories about beauty are oriented to the stimulus world, and this is an example, the golden ratio, that somehow that's important. And some studies are focusing more on the internal experience, what causes beauty inside here in our heads. This is more related to the question, are certain ratios, do they have special significance to us? I'm not an expert in this, but I know that people who study design pay attention to things like that. And I might, because I'm not formally trained in art and in artistic design or architectural design, I might find something aesthetically balanced or pleasing without even knowing that the reason was it followed the golden ratio. So yes, it might be that certain geometries visually have a special impact on our understanding of a whole scene, but I don't think it has any special neural importance to the overall experience of beauty in a more general sense. It has more to do with the way we cognitively put together scenes across space.
Russell, to finish our talk, Professor José Aparecido, você quer falar ainda alguma coisa? Eu tenho uma última pergunta só.
No, I want to give my congratulations, many thanks. I learned a lot.
Thank you.
I hope
Eu tenho uma última pergunta. Opa, uma última pergunta para o Russell. What do you prefer? A painting made in Altamira's cave or made by ChatGPT?
Now there is a good question. Because com certeza ChatGPT can do it. It could do it.
Yeah.
This is a very important question, you know, whether we, you know, it's like the test of the Turing test for intelligence, right? Can you tell that was made artificially? And, you know, I'm pretty sure that it won't be long before we cannot tell the difference. But there's the question of creating stuff. Like, could AI, or maybe not now, but in the future, could AI compose a choreography that would rival George Balanchine of the American Ballet Theater that someone could dance to? Maybe. Could it? It might be able to compose a piece of music that Stravinsky, if he were alive, would say, "Wow, I am just a student now. That's real music. I don't know what music is."
Yeah.
It's a very difficult, important question.
So, Professor Russell Hammer, thank you very much.
Oh, meu prazer. É honor completamente para participar.
Nós agradecemos demais. Espero que nenhum tornado, nem furacão passe perto da sua casa aí na Flórida, passe bem longe. Você fique seguro e protegido.
Oxalá que pode visitar-me algum dia aqui.
Ah, se puder, você.
We're going to have a good time.
Yeah. Obrigado, Russell.
Obrigado por your compliments.
Obrigado.
Nice meeting you again.
Givago,
Okay.
Givago, está me ouvindo?
Estou ouvindo.
Yeah.
Você pode... Alguns perguntaram quando será a próxima aula. Você poderia responder rapidamente?
Ok.
A próxima aula é na quarta-feira.
Vou sair agora, ok?
Ok. Tchau,
Tchauzinho.
Russell.
Tchau.
A próxima aula é na quarta-feira com o professor Michael Myler.
What? Yeah, obrigado.
Ok. Então, a próxima aula na quarta-feira com o professor Michael Myler, da Universidade de Santa Bárbara, Universidade da Califórnia de Santa Bárbara, justamente o laboratório que a gente teve a primeira vez usado o nome neurociência cognitiva, e ele vai falar sobre um tema chamado split brains, os cérebros separados, pessoas que vivem com pouquíssima comunicação entre os hemisférios cerebrais, das coisas mais interessantes que a gente vai poder ver aí nos últimos anos. Tá ok? Então, professor José Aparecido, ninguém perde essa aula aí na próxima quarta-feira.
Boa noite. Imperdível a aula.
Imperdível.
Da origem. Da origem,
isso mesmo.
Diretamente da fonte.
Isso. Boa noite a todo mundo. Tchau, tchau. Tchau, professor.
Tchau, Givago. Um abraço. Obrigado. Obrigado a todos.